All right, so continuing on, this might take two more videos. I'll try to do this in a couple. So we have this one, a physics student skiing downhill accelerating at a constant 2 meters per second squared. And by the way, if you need more practice, you could probably find a bunch online, but there's a good chance just erase everything and retry it. And if you can get these over and over again, you're probably going to be good for most of these problems you find. All right. So a good thing, once again, is let's just find everything they've told us. So acceleration is 2 meters per second squared. Takes her 15 seconds. Cool, we have a time. Those are two very good variables to have. They asked us the length of the slope. Now, physics students skiing down the hill, doing all this stuff, it might be hard to tell what they're trying to say here, but they're trying to say whatever the student is doing, that's going to be the length of the slope. And if I assume I'm starting at 0 meters, then I'm looking for x, essentially. Another thing I can kind of assume, they don't tell you this, and this is a bit of a stretch here, is that I'm going to assume that I'm starting at 0 velocity. And you might say, like, isn't that kind of a big thing to assume? And maybe it is, but if I don't, then if I try to make a graph here, if I can't assume it's like here, then I would have to assume like this is what my graph looks like, some variation of this, and that would just make the problem actually impossible to solve. So without knowing where it's starting. So I'm just going to assume that that's where it's starting. 15 seconds. I don't know my v. I know the slope is, we said 2 meters per second squared, and I said this area is, I don't know the area. I'm trying to find the area. So I don't know what delta x is. So, all right, so I don't have the area. I have the slope. I have the time. All right, so let's go back to my equations. Let's see what I can use. So I want delta x, but I don't have v. I want delta x, but I don't have v. Oh, look at this first one. It's missing v, but I have everything else other than the x's. So I'll use equation 1. So once again, this is 1. If you work through this, I would try to use this graph. You're probably going to end up substituting again somewhere along those lines. So might as well use equation 1. 1/2 x is equal to 1/2 at squared plus v naught t plus x naught. All right, well, I'm solving for x. A is 2. T is 15 squared. Square comes from t squared. That's in the formula. V naught, 0. And it doesn't matter what t is. So whenever you get these zeros, remember, it's not going to matter. I could put 15 there, but it doesn't matter. This is 0. This is 0. The only thing that matters is front half. This becomes 1. X is equal to 15 squared, or 225 meters. All right. I could have done the whole substitution again with this. If you work this problem out and you get 225, that might be a nice thing for you to try out, see if you can get 225 again. I'm going to move on more for the sake of the video. So problem 6. All right, so this dog is running down the driveway with an initial speed of 5 meters per second for 8 seconds, then uniformly increases his speed to 10 meters per second in 5 seconds. So if you haven't done this problem, this is one I highly recommend you make a graph for. Make me a VT graph. Make me a VT graph, and you make it now, and I'll show you what I would do for it. So, all right, hopefully you've had time to make your graph. I highly recommend you do. It would be good practice for this one. So this dog is doing two things. He's actually traveling at constant velocity, this first part, and then constant acceleration, the second part. So what that will look like is 5 meters per second for 8 seconds. And then the next 5 seconds, he accelerates to 10 meters per second. And he does that in 13 seconds. So hopefully this graph makes sense to you. Now, the first part actually kind of doesn't really matter if you drew this graph right or not, because you just need the acceleration part. And so that's going to be, the slope again, a is equal to delta v over t. You can use equation 2, whichever one. And that's going to be 10 minus 5 over, now the time range is 13 minus 8. So it's going to be 5 over 5, or 1 meters per second squared. That one's not too bad. But then they ask, how long is the driveway? So how long is the driveway? I'm checking my time. All right, my time's good. Checking how long is the driveway. So that's a delta x term they want. Now, I didn't really write the equations out because I kind of knew this problem is going to be very easy to solve with the graph and not very easy to solve with the equations. I remember, displacement is the area underneath the graph here. Now this shape here, it's not a trapezoid. This part's a trapezoid. This part's a rectangle. What it ends up making is this kind of 5-sided shape here that's a little irregular. But I know I can split this up. This part is going to be 5 times 8 or 40 meters. This part's going to be 5 times 5 or 25 meters. And this will be 5 times 5 times 1/2. The 1/2 is because it's a triangle, 25 meters. I add them all up. And I get 77.5 meters. All right. Had I not done the graph, what I would have to do is set up a problem, and I basically just have to realize that, I'm going to use equation 4. Delta x is equal to v initial plus v naught, or v final, over 2 times t. So I'd have to use this setup, but I'd also have to remember, and he ran at v initial times t of the first part. And this is where it gets confusing. This t is for the back 5 seconds, and this t is for the front 8 seconds. So explaining it through the equation, it's a little bit more difficult. But if you just drew the graph and, did slope or area or whatever you need, you can solve that problem pretty straightforward. All right, I'm going to move on so I can keep the video time down. All right, mountain goat starts a rock slide and the rocks crash down the slope 100 meters. If the rocks reach the bottom in 5 seconds, what is their acceleration? So, I'll draw the VT graph really quick. Now, I'm going to assume this is a case of some people, they see down, they say that's negative. And there's a way we can solve this problem where we go into the negative and we try to solve it that way. But my suggestion is we're still in one direction. Just make everything positive as much as possible. So I'm going to say it's speeding up. I'm going to say it starts at 0 again. I don't know its final velocity. I do know it's 5 seconds it takes to get down there. I know this area here is 100 meters. But I don't know anything else. I don't know final velocity. I don't know slope. So, all right, how am I going to solve this? Well, let me go to one of my equations again. So I go over here. I'm looking for one that has acceleration in the variables I need. I don't have v, so I probably don't want to use 2 or 3. This one doesn't have a. Let me try 1. And if you pick a wrong equation, just, you can still, if you can solve for something, maybe just solve it and see if that helps you with another equation. So I plug this equation in. All right, I know I'm going to assume x is 100 meters, making this one 0. 1/2 a is what I'm looking for. T is 5 squared plus v naught t. I'm going to say it starts at 0 again. See this nice little trick. If you start at rest, it actually always makes that part pretty easy. So anyways, all right. So I'm going to get 100 divided by 1/2. It's 200, not 50. Divide by 5 squared, 25. I'm going to get a is equal to 8 meters per second squared. I'm skipping the math because I assume that you will eventually be able to get there. All right, let's check the time. All right, I think I can get these two problems down, at least this next one. This next one's probably the more important one. So they tell us a car whose initial speed, all right, initial speed, I love getting that. V naught's equal to 30 meters per second. Slows to 10 meters per second, my final velocity. And this takes 5 seconds. They want us the acceleration of the car, and they want us to determine the distance it travels in the 3rd second. Let me do that first part first. So I've got this car. It's going from 30 to 10 in 5 seconds. So this is 10. It's at 30. All right. They want the acceleration. Okay, that's easy. It's the slope. It's going to be negative 20 over 5. I'm going a little quickly because I think we've done so many slopes. I think you've got it. So that's part A. Part B. Now this gets people a lot, and when I first read it, it's hard for me to tell sometimes what's happening. So I have all these seconds here. 1, 2, 3, 4, 5. All right, great. They want the distance traveled in the 3rd second. So that might sound like I go to 3 and I take the area here, but that's not what they're saying. They say the 3rd second from 2 to 3 seconds. So it's very specifically this part here. this very strange irregular shape. How can I get that? Well, I solve for the acceleration, and basically I'll zoom in on this area here. It's like a really big trapezoid, but it's really this triangle and this rectangle. Now the base of these shapes, we're at 2 seconds and 3 seconds. And the base of the triangle, there's 0 meters per second here. And there's a speed here, and there's a speed here. This speed, if I remember back on the slope, is whatever my velocity is at 3 seconds. And this speed is whatever my velocity is at 2 seconds. So, if I'm trying to solve all these areas here, basically I know this area is going to be v2s times 1 second. Let me show you slower. So the area of the rectangle, this side is going to be v2s minus 0, the difference between like this length here, and this length is going to be 3 minus 2. And so that's where I get v2s times 1. So whatever my velocity is, basically I'm going to travel in that second. This area here is going to be 1/2 times the base, which is 1 second, times the height, which is the difference between v3 seconds minus v2 seconds. So anyways, this is all taking me back. What is my velocity at 2 seconds, 3 seconds? Now, one way I can solve this is I can just use my slope formula, and I can say, hey, my acceleration is -4. My final velocity. Now, if my initial velocity is going to be at 30, well, what if I just find the velocity after 2 seconds? And so I like this problem because it's showing you this time is not necessarily the full time. It's whatever you need it to be. So I'm using this slope formula, but I'm basically saying, hey, I'm only grabbing this part of the problem. And so if I plug all this in, I'll get -8 is equal to v2 minus 30. I add 30 to the other side, and I get that v2, my velocity at 2 seconds, is 22 meters per second. I can use the same logic to get v3. So I challenge you to do the same thing, but for v3. You could solve it all. You'll get v3's 18 meters per second. Now, even though you can use the equations to do that, what I would say is there might be a more logical way to do this, and you can't do this all the time, but I know my rate of change is -4. That means after my first second, so after 1 second, my 30 meters per second would drop to 26. And then the second would drop by another 4, 22. And another second, 18, which is the numbers I'm getting here. The next second, 14. The last second, 10, which matches with my data here. So you didn't necessarily need to do these equations. You could do it the other way, but to each their own. So anyways, I'm going to plug this in. Let's see what I get. I get this area. Now, the way I have it written, I'd get a negative number. That should tell me, oh, actually, it's the height here. This height is going to be, 22 minus 18, not 18 minus 22. I will get that this is 1/2 times 1 times 4, which is going to get me 2 meters. And this side is going to be 20. So it should be... Let me redraw my picture here. This is 2 seconds and this is 3 seconds. That's what's causing these issues. So this is 3. And this will get me 18 times 1, or 18 meters per second. I add them up, I get 20 meters. This is a tougher problem. I doubt your test will have a problem this tough. Hint, hint. So I wouldn't worry too much. But I think this is a cool and clever way to show how these equations, we aren't just like beholden to like an entire problem. We can split the problem up into pieces that we want. All right, so I'm not going to work this problem. I'm not going to make another video. I'm just going to tell y'all what these answers are. So I'll tell you that this total time should be 9.93 seconds. And this should be 7.93 seconds. His acceleration should be 5.6 meters per second squared. And what was the last one? What distance did he travel in the first 2 seconds? It should be 11.2 meters. So if you get this, you're good to go. Draw a graph, use the equations, whatever you need. This is probably one you want the graph for. So that's all I got for you. And good luck.